So we're going to look at how we solve or we graph inequalities to find what the region is on a graph that is covered by a set of inequalities. So in this particular example, we've been given three inequalities. We've got -1 is less than x is less than 2. We've got y is less than or equal to 8. And then we've got y is greater than or equal to 4x minus 4. So our first job is to actually plot lines on here. So with this one, this has got 2 lines to it. It's reasonably easy to understand. What we kind of want to think of is these lines we're replacing these signs with equals and not just the less than and more than. So either x is equal to -1 and x equals -1 is this line here. Everywhere along that line x equals -1, and on the other side we've got x equals to 2. So I'll draw that line in there. Now, in terms of narrowing down the region that's actually going to fit all of these, this is showing us that our x has to lie in between these two numbers, these two lines. So that automatically means that all this space over on these sides is not included in our region. So we're now going to look at the next inequality and put that on. So we've got y is less than or equal to 8. Here we're going to see it, the line, as y equals 8. So where does y equal 8? Y equals 8 up here. So I'll draw that line in. Typically draw the lines all the way across your diagram, your graph. Okay, now it tells us here that y, and I was a bit naughty there, I apologise straight away, okay. These ones only have less than or greater than signs, so technically I'm afraid these lines should have been dotted lines, dashed lines, rather than solid lines. Whereas this one, which is y is less than or equal to 8, can be a solid line. Okay, so y has to be less than that line, so we can now eliminate that top section there. So we're now down to this part here. So now we're going to move on to our final inequality here. So we've got y is greater than or equal to 4x minus 4. So if I write that as an equation, so this is the equation of a line, so we need to plot this. I'm not going to go into the plotting. If you need to learn about plotting, look at a different video. Okay, so it's going to go through at -4, and for every 1 it goes across, it's going to go up 4. So, or another way you can think about it is when x is 1, you'll have 4 times 1, which is 4 minus 4, and that gives you 0. And then as we go across 1 again, it's going to go up. So you just need 3 points really so that you can get the gist of where your line is going through. So let me draw that one in. Now this one can be solid because it was equals as well as less than. Okay. So let me just label up this diagram. So we've got x equals -1 there, x equals 2 here, this line here is y equals 8, and this slanty line that we've just put on is y equals 4x minus 4. So we've narrowed things down to this region here, which we've now split. So the region that is ours is either this section at the top or this section at the bottom. So how are we going to prove which one it is for certain? What we're going to do is pick a spot, a coordinate in one of them. So you want to pick a nice coordinate, so pick it so it matches numbers. So for example, I'm going to pick this point here, and this point here is the coordinate 1, 4. So x equals 1 and y equals 4. Now we know it fits in between these two, and we know it's below this, so we don't need to worry about this. So what we're really testing it on is this final one here. So I'm going to substitute these values into it, but with this sign here. So our y is 4. And that's supposed to be greater than or equal to 4 times x, which is 4, minus 4. And that is 0, of course. So is 4 greater than or equal to 0? Yes, it is. So this is actually the region that we're interested in, and they commonly ask you to label it with an R. Just to prove that it wouldn't work in this area, I'm going to come down here and let's pick this spot here. This one here is 1 minus 6. That's the coordinate. So I'll do it over here because I've run out of space there. So we've got y is supposed to be greater than or equal to 4x minus 4. So here our y is minus 6. Is that greater than or equal to 4 times 1, which is 4, minus 4? 4 minus 4 is 0. So is minus 6 bigger than 0? No, it's not. So this region is not included. So the region we're interested in is here. So I'm going to do some more examples for you. So we've got a fresh one here, and we've got x is less than 3, y greater than minus 3, and y greater than 2x. So we'll start with the first one. So the line for this one will be x equals 3. And I'll try and remember that it should be a dashed one this time. Sorry for last time. Okay, so x equals 3 all the way along here. So I'm just going to dash that line to show that x can be less than this, but it can't actually be on this line. That's what we're effectively showing here. So that's our x equals 3 line. And x has to be less than 3. So that means that this area here is not part of our region. So now let's look at the next one. So we've got y is greater than minus 3. So we're looking for y equals minus 3, which is this line down here. Again, it doesn't have the extra equals sign, so it needs to be a dashed line rather than a solid line. Okay, so that one there is y equals minus 3. And it tells us here that y has to be greater than minus 3, so it has to be above that line, so we can get rid of that region there. So finally, we've got this one. So we're looking at the equation y equals 2x. So it doesn't have a c part here, which means that one of the places it goes through is going to be there. So when x is 1, y will be 2. When x is 2, y will be 4. So here's our y equals 2x line. Again, needs to be dotted. So I'm just trying to get it lined up as accurately as I can. There we go. That's as good as it's going to get. With a big chunky pen, it's a bit of a challenge. Okay, so we've got that line there, and that is the line y equals 2x. So we've got this region here, which is split into 2 parts, and we've got to figure out which part it's in. So I'm going to pick a point in one of the regions. Okay, so I'm going to pick, just to be a bit contrary, I'm going to pick this one here. So the coordinates of that point there are -2 and 4. So x is -2 and y is 4. So we know that we've taken care of the first two inequalities by using these lines and eliminating here. So it's all about this third one. So y has to be greater than 2x. So let's substitute here. Our y is 4. So 4 has to be greater than 2 lots of x. So x is -2. 2 lots of -2 is -4. Is 4 bigger than -4? The answer to that is yes. So actually this side of the line is the region we're interested in. Okay, I'm not going to go through and prove it again, but this side is not included. If you tested out a point in that line, you'd find that it doesn't fit this inequality. So let's do another one. Okay, so here we've got x is less than or equal to 2, y is less than 2x, sorry about that y, -2, and here we've got x plus y plus 2. I'm going to write it up here for the minute. We've got x plus y plus 2 is greater than 0. Now, in order to be able to plot that, we need to transform it into y on one side and everything else on the other side. So in this case, that means that we will have y is greater than. So to remove the x, we do -x. So that means we'll end up with a -x on this side. And to remove the 2, we do -2. So we'd end up with a -2 there. So sometimes you've got to transform these before you can do that. So we'll start with the easy peasy one, which is here. So we're going to put in the line x equals 2. So x equals 2 is this line here. I can do it solid this time because it's got the equals bit underneath it. So that's our x equals 2 line. So the next one we're going to do is y equals 2x minus 2. So I know that it's going to go through -2. And because it's a 2x, for every one I go across, it's going to go up 2. So I'm just putting in my points. So I'm not dwelling on the plotting here because that's not really what this video is about. Okay. So that there is our y equals 2x minus 2 line. So now we've got a third line to put in here. Oh, I forgot again. That one should have been dashed. Let me try and remember on this one. This one has to be dashed as well. So y is greater than -x minus 2. So y equals -x minus 2 is what we need. So this one also goes through this point, but this one goes down 1 for every one we go across. All right, just to sort of prove the point. So when x equals 1, y would be -1 minus 2, which is -3. So you can see it's gone down 1 as we're going across here. So it's a negative gradient, so we should expect to have the line here that's going, just get it lined up as best I can, in this direction instead. So that is our, oh, I forgot again, didn't I? Sorry, dash it. Dashed line, not solid line. Try and be more careful than me. Hopefully you won't be trying to explain it to someone else at the same time. Oh, let me not put that there either because that's going to make life difficult. Okay, so that line there is y equals -x minus 2. Now this time, oh, we've got more possibilities for where it could be. So we'll start with this one. So our x has to be less than or equal to 2. So that does mean that all of this side is out. But that still leaves us with 1, 2, 3, 4 parts. So you may have to test all 4 to find the right one, but commonly it will be the one that's actually forming a triangle. So I'm going to try that one first. So this point here is the coordinate 1, minus 2. So x equals 1 and y equals minus 2. Now this time we need to try it against 2 of these inequalities, not just 1. So first of all we need to try it against the y is less than 2x minus 2. So when y is minus 2, x is 1, 2 times 1 is 2, minus 2 equals 0 on this side. Is minus 2 less than 0? Yes, it is. So now we need to try up against our second inequality. So that's y has to be greater than minus x minus 2. So y is minus 2. Is that greater than minus x, which is minus 1, minus 2? So minus 1 minus 2 equals minus 3. Is minus 2 bigger than minus 3? Yes, it is. So we got lucky and we found our region first time through. But you can go ahead and check the other regions to see that none of those would have worked with these inequalities. So we've looked at now how to draw the inequalities onto a graph. So hopefully you get the concept there. If you're not confident with plotting your lines, I suggest you go and revise that before you have a go at this topic.